Hello students, this is Dr. Faizan Mirza. I'm discussing with you the details regarding the kite diagram and how the systematic sampling is carried out. The systematic sampling actually is carried out for assessing biodiversity in a region when there is a changing abiotic factor across the region where you are carrying out the sampling. For example, the altitude is changing, soil moisture content is changing, or soil type, pH, sunlight exposure, if the terrain is changing. So any physical factor, any factor which is affecting the abundance and the species diversity in that region. In that case, you can't use random sampling because randomly placed coordinate will give you a widely varied result, whereas an abiotic factor is actually controlling or governing the distribution and the abundance of that species or the species diversity in that region. So what do we do? In systematic sampling, we carry out either the line transect or interrupted belt transect. There are two ways in which we can do that. What's a transect? Transect is basically a measure tape, a line that runs across the changing abiotic factor. For example, if you are tying a transect from across this region, this is a line transect. So what do we do? We start from this point. This point, for example, is the end of the river bank. So from here you can say that the river is flowing across here, so the moisture content here is very high since the soil will soak up a lot of water. And as you move away from that river bank, you are going away, you are going distant from the river bank, so the soil moisture content will keep on decreasing. So obviously we know that if there's the moisture content is changing, then diversity will change as well, because there will be some plants which will be adapted to a high moisture content as compared to low moisture content and even much lower moisture content, so on and so forth. So what do? We tie a transect. Transect is a measure tape. We tie that from the point where we want to start an investigation from to a point where we can stretch it to. For example, here we stretch it to a distance of 20 meter, for instance. So this is this and we'll just tie these knots. So this represents 0 meter, this represents 1 meter, 2 meter, 3 meter, 4 meter, 5, and so on and so forth. So what are we having? We'll just keep on recording the species. We'll catalog them, we'll count them, and we'll just mention how many of these are present at each meter, and how, for example, these three plants are present at 0, 1, and 2 meters. But beyond that, there's these plants, a different species of plant is there, and then a different species, and so on and so forth. So that's what we do in the line transect. What do we do in interrupted belt transect? In interrupted belt transect, again we tie a transect from the point where we want to start our investigation from to a point where we want to end it, and we just start to place coordinates at equally spaced points in that region, and we start to account for the abundance within the coordinate of that particular region. How do we report this data? The belt transect data can be reported or displayed on a kite diagram. In a kite diagram, on y-axis we take the changing abiotic factor, on the x-axis we take the species or the variance that we have just counted. For example, this diagram shows this data shows to you that an abundance scale was used, and the seaweeds and mollusks were counted, and the scales of 5 to 1 was used. So if the species was lowest, it was regarded as 1. If it was highest, it was recorded as 5. If it was regarded as 0, that means that the species was just not present in that coordinate in that region. So for example, kelp, you can see the distance changing across the shores is 0, 20, 40, 60, 80, and so on and so forth. The distance is changing, and you can see how the kelp is changing. So if at 0 meter kelp is 3, it means this is the abundance of kelp at 0 meter. But if you go to 20 and then you keep on going forward, kelp is just absent altogether. Come to serrated rack. Serrated rack, you can see at 0 meters is 5. It means more abundant than kelp, and at 20 it gets a bit lesser than it was at 20 at 0, and then again it's 5, 5, 5 each till 100, and beyond 5 it's 0 again. So if this kind of data is given to you, how do you represent this data? This data can be represented on a kite diagram. In a kite diagram, we take on the x-axis the species that we have counted, on the y-axis we take the changing abiotic factor, which in this case in the distance in meters from the shore. So we place the distance from the table here. We just mention these distances on the y-axis, and for example, the first kite will be made for kelp. Kelp is abundant is 3 here, and 0 at 20. So what will we do? At kelp, we'll just use 3 squares to represent 3 units here. So I'll just draw a line here to represent 3 units, and at 20 I'll point a 0 because the species is not present there, and my kite will be actually a triangular shape. Then for serrated rack, you can see it's 5 at the bottom, then 4, then 5, 5, 5 each, and it continues 5 till 100, and then it becomes 0. So what will we do? We'll again use the same kind of abundance. We'll use the same notation that we use here. If 3 squares were representing 3 units here, I'll use 5 squares to represent 5 units here. There must be gap between these two bars, these two kite diagrams, these two kites in fact. This broad base represents 5 units, this at 0 meter. Then then these 4 units represent a lesser quantity or lesser abundance at 20, and then again it starts to increase to 5, 5, 5, 5 each till 100, and at 120 we have it 0. So we know this is the kind of kite that we'll be getting for C-rated rack. So for example, dog whelk, you can see dog whelk is just absent here at 0. It's absent at 40, and at 20 you can see that its abundance is very low as compared to all the kites. So you can probably interpret this. We go to dog whelk. What do we see? In dog whelk we see that yes, it's 0, 1, 0, 0 at 0, 1 at 20, and 0 at 40. So this one is represented by 1 unit width in this region where the dog whelk was shown to you. So for example, rough periwinkle is showing to you abundance at 2 points in this data in which the transit were tied. So you can see that it's abundant here, it's abundant here, and in between in these regions it's just absent. So this is how the kite diagram is used. Kite diagram is basically just a bar chart, but in this bar chart we are representing the width of the bars with the abundance, and we need to make sure that we place gaps in between. So because this is not a continuous data here. That's it. I've already covered how the Simpson index of diversity can be used to calculate how much diverse is the region. So that's pretty much the repetition of the same. So I'll just end this. Thank you so much.